This has been provided by the James Webb Telescope, the oldest and most precise image of Proxima B, revealing amazing information about this exoplanet that could be habitable. As we set out on an adventure through space to uncover the mysteries of Proxima B, we endeavor to determine whether it is, in fact, a fascinating planet that exists close to Earth. Located within the star's habitable zone, Proxima B is not your typical rocky exoplanet, it's a relative of Earth. Located 4.2 light-years from us, this planet remains mysterious. Could there be another Earth, with oceans and life thriving on its surface? However, there's more to Proxima than meets the eye. Alone within the red dwarf's orbit, it has a companion whose identity is still unknown, an additional secret the star system holds. Perhaps we are not alone. We haven't fully discovered Proxima Centauri B yet. Interestingly, it essentially receives the same amount of energy from its star as Earth does from the Sun. Could this genuinely indicate that there may be water, or even life, on its surface? As we venture beyond our own solar system, we encounter a vast universe of exoplanets orbiting stars other than our Sun. With more than 200 billion stars in the universe, the options for exoplanets are endless. Some may even be free-floating, not tied to any star, space explorers adrift like rogue stars. Proxima Centauri B stands out among them all as a particularly striking and fascinating planet. Its year lasts just 112 Earth days, and it orbits its star at a much closer distance than Earth does to the Sun. This likely means that one side of the planet is constantly covered in sunlight, while the opposite side remains in eternal darkness. Let's talk about this. The star that Proxima B orbits, Proxima Centauri, is a component of the Alpha Centauri triple star system, which also includes Alpha Centauri A and B. These stars form the closest star system to our own solar system. The binary system of Alpha Centauri A and B appears as a single bright point in the constellation Centaurus and is the third brightest star in our night sky, with a magnitude of less than 2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf star located 4.24 light-years from Earth. Despite being the closest celestial neighbor, it cannot be seen by the naked eye. It has an apparent magnitude of 11.13, significantly fainter than the visible limit of 6.5. But don't be fooled, Proxima Centauri is still a star to behold. Dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. They may not generate a great deal of energy, but thanks to their core convection processes, they shine for tens of billions of years. In fact, Proxima Centauri could remain a stable main-sequence star for an additional 4 trillion years. However, its ability to support life is still up for debate. Proxima Centauri is a flare star, which means it experiences frequent and significant variations in brightness. For a star with such a low mass, the habitable zone would be much closer than the Sun's, between 0.023 and 0.054 Australian dollars, but that doesn't mean it's livable. Proxima B appears to be bombarded by a large amount of ultraviolet light from its star, far stronger than the radiation we receive from our Sun. This radiation is so potent that even the lightest particles, like hydrogen, could be stripped away, not to mention nitrogen and oxygen. Just because a planet is in the right location doesn't mean it can sustain life. Proxima B may not have a stable atmosphere, which is crucial for temperature control and maintaining a water-friendly surface. Without it, all living things would be vulnerable to harsh space weather, making life nearly impossible. So while Proxima B may appear Earth-like, it's far from supporting life. Many remain skeptical for various reasons that make it uninhabitable. Still, the endeavor to uncover the truth about Proxima continues. One instrument that has captured astronomers' attention is the James Webb Telescope. After several delays, the telescope was finally launched in 2018 and will help determine whether life exists on Proxima B. As with many scientific endeavors, success is never guaranteed. The telescope required various modifications to ensure it delivers accurate images. Abby Bend, a theoretical physicist at Harvard, explains that if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope is designed to detect infrared light, capturing photographs of that light on the planet's surface and searching for patterns that may indicate the presence of water or an atmosphere. But what if the atmosphere isn't conducive to life? The presence of an atmosphere doesn't guarantee the existence of life. Ed Turner, an astrophysicist at Princeton University, warns that Proxima B could resemble Venus, with a thick atmosphere denser than Earth's, accompanied by extreme heat that would make life impossible. The journey to discover Proxima B's secrets doesn't come without its challenges. As long as the James Webb Telescope is in use, we must consider additional factors, like astronomical costs. Still, Scientists feel pressured to figure out a way to observe planets like Proxima B. The stakes are high, but so are the rewards. The opportunity to investigate the unknown and unveil secrets of a distant planet that could hold the potential for life. If this exoplanet were habitable, could we one day visit? Due to its proximity, Proxima B is an especially exciting candidate, like exploring our infinite backyard. Even more captivating is that it's roughly the same size as Earth, and its location in the habitable zone suggests it could indeed support life. Proxima B's proximity also makes it a perfect target in our quest for life beyond Earth. Though we can't go there yet, it's definitely on the agenda for future missions. As technology advances, it's one of the most exciting prospects in space exploration. However, this is no easy task. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. Despite this, a solution has been proposed: extremely thin solar sails. A spacecraft propelled by these sails could travel to the Alpha Centauri system, using solar pressure to stay on course, eliminating the issue of fuel. Even cooler? This cutting-edge technology might offer insights into otherworldly life on Proxima B. But as with all ambitious ideas, there are limitations. For example, having an atmosphere doesn't necessarily mean there's life. Proxima B could be akin to Venus, thick, hot, and hostile. The James Webb Telescope can detect such atmospheres, even if the brightness of the illuminated side is only 5%. 5% may not seem like much, but for a star quieter than our Sun, it's significant. If Proxima B has advanced technology, it might even be using orbital mirrors to reflect sunlight from its day side to its night side. How cool is that? What's more fascinating is that numerous exoplanets exist in our universe, waiting to be discovered. These planets vary in shape and size, some enormous gas giants, others similar to Earth. One type that's captured scientists' focus is the gas giant, planets like Saturn or Jupiter, but even larger. Some are dubbed superjupiters, dominating the scale. Some gas giants orbit very close to their host stars, thriving in fiery environments with temperatures high enough to melt metal. Imagine seeing such a planet up close, with ferocious storms and intense heat. Imagine a universe where the night sky is brimming with stars, and each star is potentially home to a world of its own. Some barren, some frozen, others blazing hot. And perhaps, a few, teeming with life. As we dive deeper into the mysteries of Proxima Centauri and its planets, B, C, and the potential D, we are reminded of how small and yet how bold humanity is. With every advancement in technology, from the James Webb Space Telescope to theoretical light-sail spacecraft, our vision stretches further into the cosmos. Proxima Centauri B, the rocky super-Earth, remains the star of this interstellar drama. Its location in the habitable zone, its size comparable to Earth's, and the tantalizing hint of a stable orbit, all paint a portrait of a planet that could, in theory, host life. But it is not without its dangers. The violent flares from its red dwarf star and the uncertainty of an atmosphere throw shadows of doubt over its potential. Yet, these shadows don't extinguish hope, they only make the discovery more thrilling. Proxima Centauri C, orbiting farther out, might not be in the habitable zone, but its possible ring system and unusual brightness raise fascinating questions about planetary formation and diversity. And if Proxima Centauri D, the whisper of a planet, is real, it could shift our understanding of how common multiplanet systems are around red dwarfs. In the grand scale of the universe, we are just beginning to scratch the surface. With over 200 billion galaxies, each with billions of stars and countless planets, the idea that Earth is the only cradle of life feels increasingly unlikely. As we look at Proxima Centauri and imagine future missions, perhaps robotic probes or even tiny light-driven spacecraft sailing across interstellar space, we aren't just chasing distant rocks. We're chasing connection. Connection to other worlds. Connection to a greater cosmic story. Connection to the idea that we are not alone. So whether Proxima B turns out to be a second Earth, a second Venus, or something else entirely, the journey of discovery is just as important as the destination. We stand at the edge of possibility, with eyes turned to the stars, hearts filled with curiosity, and the tools to find answers. And perhaps, one day in the not-too-distant future, someone will look up from the surface of Proxima B, and look back at Earth, wondering if anyone is out there, just as we do now. Numerous additional planets, each with its own unique structure and orbit, fill the universe with unexpected discoveries. Exoplanets are just one aspect of it, with new discoveries being made all the time. It's a thrilling time to work as an astronomer, even though we do not yet have an exact count. We do know that exoplanets exist, but given that we are aware of the stars that illuminate the universe, however, exoplanets are difficult to find, requiring advanced technology and telescopes for locating. These planets are frequently obscured by the spotlight cast by their host stars. Despite being difficult to study, with the direct result of technological advancements, exoplanet imaging is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by the telescope, sufficiently far away from its host star to avoid being obscured, and young enough to be hot enough to be seen from Earth. These criteria limit the number of exoplanets that can be directly imaged, but they provide fascinating glimpses into the characteristics and composition of exoplanets from these distant worlds. Exoplanets are most frequently found by using the changes they bring about in the stars they host. The pull of an exoplanet's gravitational influence can cause its host star to shake, and the resulting radial velocity may be detected. The Kepler Space Telescope utilized the transit method, determining how much a star's light has diminished when an exoplanet passes by. This method has been extremely helpful in gathering information about exoplanets, including their size, distance, and temperature. Did you know that there are some interesting facts? More than 22% of stars, including the Sun, have planets the size of Earth in their habitable zones, or the TRAPPIST-1 system, where 7 rocky exoplanets with water on their surfaces are found. Exoplanets in our solar system's natural satellites can also be part of the system, with over 4,000 known exomoons. Exoplanets that have been discovered thus far exist in abundance throughout the universe. Hot Jupiters, due to their mass and rapid rotation, are the easiest to detect. However, numerous other exoplanets are still waiting to be discovered, and NASA's James Webb Space Telescope is revealing the secrets of the universe, one discovery at a time. This extraordinary telescope has been gathering information and taking stunning images of the universe being revealed. It has recently produced wonders previously unknown and made headlines with a groundbreaking discovery that will alter our understanding of the universe forever. NASA disclosed that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides vital details regarding the planet's composition and development, giving us a glimpse into the secrets of the universe. This gas giant planet orbits a Sun-like star 700 light-years away. This finding is a significant milestone in our quest for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery will provide us with a new perspective on the universe, igniting excitement among the world's scientists and astronomers. But the James Webb Space Telescope goes beyond that. The telescope has been recording extraordinary photos and data in infrared light. An emerging young protostar, 110 IRS-4, shows off the cool, wispy cloud material, while the orange dots in the background are distant stars that the ice has obscured. This remarkable study is part of the Ice Age project, which aims to investigate how ice evolved from its formation and contributed to the onset of cold comets. That's not all. The James Webb Space Telescope has also mapped the inner workings of a dusty disk surrounding a red dwarf star in the vicinity. Imaging it for the first time at these light frequencies in the infrared, this discovery provides significant insights into the formation of planetary systems and could assist us in understanding how our own solar system formed. The James Webb Telescope has provided unparalleled views of Proxima B, revealing exciting possibilities regarding this habitable exoplanet. As scientists study this fascinating planet in the host star's habitable zone, their goal is to determine whether it might be similar to Earth. Proxima B is just 42 light-years away and is frequently referred to as Earth's cousin. The possibility of water and life existing on its surface has generated significant curiosity. Proxima B revolves around Proxima Centauri, a red dwarf star that is one of the stars in the Alpha Centauri system, along with Alpha Centauri A and B. These stars are the closest to our solar system, and although Proxima Centauri is the faintest of the three, it is a stable star. Red dwarfs like Proxima Centauri have long lifespans and are among the most efficient at generating energy for trillions of years. However, they can also exhibit intense stellar flares that could be problematic for any potential life on nearby planets. The possibility of life on Proxima B is still debated. Despite being in the right zone, it might lack a stable environment essential for protecting potential life from harmful extremes in temperature and radiation. Proxima's prolonged exposure to ultraviolet light emitted by its star could eliminate essential components like hydrogen, nitrogen, and oxygen, creating harsh conditions. Many scientists remain skeptical, noting that while the planet appears to be in an Earth-like position and size, the actual circumstances might not be favorable for life. The James Webb Space Telescope is very important in investigating these questions. Launched in 2018, it is designed to observe infrared light, which can provide insights into the composition of exoplanet atmospheres. For instance, if Proxima B has a climate that stores heat or contains vapor, the telescope can detect these signatures. However, astrophysicist Ed Turner warns that the mere presence of an atmosphere doesn't ensure the habitability of Proxima B. It could end up like Venus, with a thick, hostile atmosphere and extreme temperatures. The quest for understanding Proxima B is not without difficulties. Observing exoplanets requires advanced techniques to counteract the glare of their host stars. Direct imaging has become possible with technological advances that allow astronomers to get a look at the features of these faraway worlds. The gravitational influence of a planet can cause its star to wobble, leading to detectable changes, while the transit method involves measuring the dimming of a star's light when a planet passes in front of it. Beyond Proxima B, the universe is teeming with exoplanets, each offering unique insights into planetary formation and evolution. Some of the most exciting discoveries include gas giants that are significantly larger than Jupiter, as well as smaller terrestrial planets that might bear similarities to Earth. The variety of exoplanets that orbit Earth include super-Earths, which can have rocky compositions and sizes greater than our planet, and hot Jupiters that revolve around stars. As our knowledge of exoplanets grows, so does our appreciation for the vast diversity of planets in the universe. The potential discovery of habitable exoplanets like Proxima B has sparked excitement and hope, encouraging the scientific community's desire to uncover the mysteries of life beyond Earth. The James Webb Space Telescope, with its groundbreaking capabilities, is at the forefront of this quest. As the James Webb Space Telescope continues its mission, it is not only enhancing our understanding of exoplanets but also offering new perspectives on the broader cosmos. The data it collects allows scientists to refine their theories about planetary formation, evolution, and the potential for life beyond our Earth. This revolution in space observation is shaping the future of astronomy, offering unprecedented details about distant worlds that were once beyond our reach. The telescope's ability to detect exoplanet atmospheres in high resolution is especially crucial for identifying key molecules like water vapor, methane, and carbon dioxide. These findings could help determine whether conditions on a given exoplanet are suitable for life or whether they are hostile to life as we know it. In particular, the discovery of biomarkers or atmospheric compounds linked to biological processes would have profound implications for the search for extraterrestrial life. James Webb's infrared capabilities also help scientists investigate the formation of stars and planetary systems by observing their earliest stages. Young stars, enveloped in dust and gas, can be observed in greater detail than ever before. This contributes to a better understanding of the processes that give rise to planets and their potential habitability. Moreover, the data from the telescope could eventually enable us to compare exoplanets to our own solar system, looking for similarities that might suggest the potential for life-supporting conditions elsewhere. Some exoplanets may share characteristics with Earth, such as being in the habitable zone of their star, or having similar compositions, atmospheres, and even seasonal cycles. As we look further into the universe, the discoveries made by the James Webb Space Telescope could shift the way we view our place in the cosmos. Its findings may help answer some of the most profound questions humanity has ever asked. Are we alone in the universe? Is there life beyond Earth? What are the conditions necessary for life to thrive, and how common are those conditions throughout the galaxy? This telescope, still in its early stages of its mission, will continue to provide groundbreaking insights that challenge our assumptions and expand our knowledge. With every new discovery, we are reminded that the universe is vast and full of mysteries, and we are just beginning to scratch the surface of what lies beyond. As the James Webb Space Telescope moves forward in its exploration, it opens up new possibilities for future generations of astronomers, scientists, and explorers, pushing the boundaries of human knowledge and bringing us closer to answers to some of the most exciting and fundamental questions about life and the universe.